Hey guys, I'm Manoj. Welcome to this chapter from the course C# and .NET for Beginners. I create contents for developers. Subscribe to my channel and press the bell icon to get the latest updates from this channel. We are going to begin our discussion with arrays. Specifically, we are going to discuss about what is an array and how arrays can be declared. We will also have a look at some interesting concepts like multi-dimensional arrays and jagged arrays. In the second part, we will discuss about collections. We will see how the collections are placed into various namespaces. Then, from each namespace, we will have a look at some commonly used collection types. Finally, we will have a coding session to demonstrate how arrays and collections can be used in the code. I hope you watch this chapter till the end. At the end, you will find some exercises that you can try on your own to ensure that you have grasped all the contents from this chapter. Let's get started. Before we begin, let's try to understand why do we need arrays and collections. Let's say we want to write a program. That program is supposed to take many numbers as input. Then we want to display the sorted numbers on the console. As we want to perform sorting on the numbers, it is pretty much clear that we want a numeric data type. Let's say we will use integer as the data type for holding the number. But according to problem statement, there can be many inputs. So, how to store many numbers? Should we declare many integer variables? And even before that, do we know what does the word many means here? Does it mean fixed quantity, which is known at the time of writing the code? Or it is not known beforehand and the program is supposed to ask user about how many inputs user wants to enter? If the count of inputs is not known, then it would be impossible to decide how many variables we need to declare. Even though the count of inputs is known and we can declare multiple variables, it may not be a wise idea to declare tens and hundreds of variables for the data which is supposed to be grouped together. Now, what is the best solution for this case? Many times our application needs to process the data which can be logically grouped together. Perhaps this logical grouping is required so as to perform same set of operations on the grouped values. We may want to get a list of all students from a given university to calculate their grades or CGPA. Or else, we may be working on a sports app where we want to get the list of all cricket players from a given team and we may want to show their top 3 performances. For such purposes, there are two options. We can either declare an array of a given type or we can declare a collection. While declaring arrays and collections, we need to specify the type and then the arrays and collection can hold multiple values of that specified type. There is one basic difference between arrays and collection types. While declaring arrays, we are required to specify the size of an array. The size of an array defines how many values it can hold. This size cannot be changed later. So let's say we declare an array initially to hold 10 elements and later in the program we decide that we want same array to hold 20 elements now. It is not possible. We will have to declare another array and then copy all the values from old array to the new array. On the other hand, collections are more dynamic. We don't need to specify the size of collection. They provide flexible ways to interact with the collections. I know this may not clarify the difference between arrays and collections. This is certainly not enough to understand how arrays are different from collections. So let's have a closer look at these types. Let's begin with arrays. Arrays can store multiple values of given type. Here is the syntax for declaring arrays. Left hand side starts with a type name followed by square brackets and followed by a variable name. The square brackets specified after the type name indicates that the given variable is an array. After variable name, there is assignment operator. On the right hand side of assignment operator, there is a new keyword followed by the type name and the square brackets. This time, the square bracket contains a number. This number basically determines the size of an array. As I told earlier, the size of an array needs to be specified while declaring an array variable. This size determines how many values it can store. Here, we have specified 8 inside the square brackets. It means that this array can contain 8 integer values as shown in the diagram below. Once array size is specified, it cannot be changed. So here, if we want to store more than 8 elements in ARR variable, it's not possible. For that, we will have to create a new array using new keyword and then we will have to specify the new size. But this would mean that the values from the older array would be gone. So we will have to repopulate the new array with the values. For accessing values from the array, we can use square brackets after the variable name. Inside those square brackets, an index must be specified. This index is sometimes called as subscript. Arrays are zero indexed. It means that if array length is n, then the index starts with 0 and the last element's index is n minus 1. The first index and the last index are also sometimes called as lower bound and upper bound of an array. If while reading a value from array, we specify an index which does not fall between lower bound and upper bound, then an index out of bounds exception is thrown. Now let's come to the values. When an array is created, by default every element is initialized with the default value of the data type of each element. For example, if we declare an integer array, every element's value would be 0 by default. This is because 0 is the default value of integer type. On the other hand, if we declare a Boolean array, each value in that array would be false by default. Similarly, if I declare array of reference type, let's say string, then the array values would be null by default. In the memory, the values in an array are contiguous, meaning they share the borders with the neighboring elements. So, if an array is fully populated, then inserting a value is an expensive task, because for this kind of insert operation, we will need to right shift the subsequent values. This slide shows multiple ways to declare and initialize the arrays. Here, I have intentionally used integer data type in first 4 examples to demonstrate various ways to declare the same array variable. Although these examples are using integer data type, we can use any other data type with this syntax. The syntax on the first line is already discussed on the previous slide. Array 1 will contain zeros in all 5 locations. The second way creates the variable and initializes with the values. The values are specified within the curly brackets. In fact, there is also an alternative syntax. We can skip new operator and data type. The right hand side of assignment operator on this line contains only values inside the curly brackets. In addition to these 3 ways, we can also declare implicitly typed arrays. For that, we can use var keyword as shown here. On the right hand side of assignment operator, there is a new keyword and a pair of square brackets. Note that this statement does not contain any data type specified. The data type is implicitly derived from the element types. That's why array 4 is an integer array. On the other hand, the last array is actually a string array, although we have not explicitly specified the data type. As discussed earlier, we need to specify index inside the square brackets for accessing a value from given array. Elements from all these arrays can be accessed by using single index. This is equivalent to a queue in which multiple people are standing. You can identify one person by specifying the position of that person from the front of the queue or from the end of the queue. This type of arrays are called as single dimensional arrays. We need to specify a single index to read the value from them. An array can also have more than one dimension. Let's now discuss the simplest form of multidimensional array, which is a 2D array. A 2D array can be thought as a table which contains specified number of rows and columns. For example, let's say we want to hold 4 movies, and for each movie we want to have 2 reviews from 2 different reviewers. In that case, we can declare a 2-dimensional array, sometimes also called as 2D array. In that array, each row will correspond to a movie and each row will contain 2 reviews. This code snippet shows multiple ways in which 2-dimensional arrays can be defined. While declaring multidimensional arrays, we need to add additional commas inside square brackets as shown in this snippet. For example, first row in the code snippet is to declare an array which contains 4 rows and 2 columns. We have not initialized values in this array, so all the values will be initialized with the default value of integer type, which is 0. In the second example, we have initialized the values for 2D array. The values for the rightmost dimension would be specified inside the innermost curly brackets. Here, in our code example, the rightmost number is 2 and hence the innermost bracket contains 2 values. Finally, let's talk about how to iterate over 2-dimensional arrays. Iterating over single-dimensional array is easy. We just need to use length property to iterate over single-dimensional array. For multi-dimensional arrays, we can use getLength method. This method can be invoked on instance of an array. It takes an integer value as a parameter. The parameter value should be a 0-based index of the dimension for which the length should be returned. For example, for knowing the length of first dimension, we can pass 0. For knowing the length of second dimension, we can pass 1, and so on. The code here has a nested iteration statement. The outer loop iterates over the rows, while the inner loop iterates over multiple values within a given single row. I would suggest you to try running this code in Visual Studio to see the output of this code. It would clarify how the nested loops are working. It would help in understanding how the values are stored in the arrays. As I was saying earlier, the two-dimensional arrays are simplest form of multi-dimensional arrays. Similar to two-dimensional arrays, we can specify arrays which contains multiple dimensions. This code snippet here shows some examples. The syntax used for declaration is very similar to the two-dimensional arrays. Instead of specifying just two numbers inside the square brackets, we can specify as many numbers as we want. For iterating over multidimensional arrays, we can use getLength method. This method will return the length of specified dimension. We already have seen the usage of getLength method on previous slide. Let's now discuss about another type of arrays, jagged arrays. The word jagged literally means spiky, something with sharp points. This name itself suggests that jagged arrays contains pointers. Jagged array is basically an array in which every element is an array. The lengths of individual arrays may not be equal. In other words, every value in jagged arrays is basically a reference to some other array. So, when you define a jagged array variable, all the values in the jagged array would be by default set to nulls. The code snippet here shows jagged array. In this case, every element in the jagged array is a single dimensional array. That's why we have used two pairs of square brackets while defining the variable. Also, note that we have specified the length of jagged array in first pair of square brackets on the right hand side. The individual element in jagged array needs to be initialized separately. Here, in this code snippet, we have used the simplest syntax to initialize individual arrays. As we can see, each array has different length. In this code example, each value in the jagged array is pointing to a single dimensional array. If required, we can also declare jagged arrays in which every item is pointing to multi-dimensional array. Let's now understand how the jagged arrays are different from multi-dimensional arrays. The first code snippet here shows a code which initializes a two-dimensional array. This array can be visualized as a 4x3 matrix as shown on the right hand side. Now, the second code snippet shows jagged arrays. We already have discussed this code on the previous slide. As you can see, every element is basically a reference to a single dimensional array. The first value from the jagged array points to a single dimensional array which contains 4 elements. The second value from the jagged array points to another single dimensional array which contains 3 elements. And the third item from the jagged array also points to another single dimensional array which contains 5 values. And lastly, the final item from jagged array also points to a single dimensional array which contains 2 values. This picture will help you to understand why these arrays are called as jagged arrays. It is because they are array of pointers. Jagged arrays are also sometimes called as array of arrays. We have seen how to iterate over multidimensional arrays and single dimensional arrays. Iterating over jagged arrays is a bit different. This code snippet shows 2 different ways. The first way is to use for each statement. In every iteration, the iteration variable will point to individual item from the jagged arrays. So that means this iteration variable will point to another array. Then inside this outer for each statement, we can nest either single or multiple for each statements, depending on whether every individual item in jagged array is a single dimensional array or multi-dimensional array. In this code snippet, we are showing the example of jagged array, which is an array of single dimensional arrays. So we just need a single inner loop. The inner for each loop will give us the individual value from the single dimensional array. This is how for each can be used to iterate over jagged arrays. Other option is to use any other iteration statement. In this code snippet, we are showing the for statement. Using the for statement is also very easy. We can take 2 index variables. The outer for loop with variable I actually iterates over jagged arrays. The inner for loop iterates over every individual item from the jagged array. For accessing individual values, we need to specify 2 pairs of square brackets. The first pair of square brackets will contain an index to get a single dimensional array from the jagged array. while the second pair of square brackets use index j to get the individual value from that array. Similarly, if we define jagged array as array of multidimensional arrays, then second pair of brackets will contain multiple indices separated by comma. I hope you find this example helpful to understand how to iterate over jagged arrays. Before we move on, here are some final comments on the arrays. I mostly have used integer arrays for demonstrations, but we can use any built-in or custom type instead of int while declaring the arrays. For example, we can declare an array to contain multiple datetime objects, or else we can also declare an array of strings, or else we can also declare array of some custom type, let's say person. Another point is, array is a reference type. So when an array is created, the array object is created on the heap while its reference is stored on the stack. When we use any data type to declare an array, we can store values from that data type only. For example, in an integer array, we can store only integer values. We cannot store double or decimal values in that array. If we want to store values of multiple types in a single array, then we can declare array of objects. System.object is the base type for all types in .NET. Whether a given type is a built-in type or a custom type, it is directly or indirectly derived from system.object. It means that if we declare array of objects, we can store any value in it. Although syntactically it is allowed, I would not recommend it. I would say avoid using object arrays to ensure the type safety in your code. Jagged arrays and multidimensional arrays can be combined. For example, we can declare a jagged array, which is an array of 3D arrays. Finally, we can also declare a jagged array, which is array of jagged arrays. So instead of array of arrays, we can declare array of arrays of arrays. This nesting can go to any level, but practically, in most of the cases, you may not need any further nesting after 2 or 3 levels. Okay, this concludes theory part of arrays. Let's now move on to the collections. Till now we have seen arrays. Arrays are the most useful for creating and working with fixed number of strongly typed objects. Then what are collections? Collections provide more flexible ways to work with group of objects. Unlike arrays, collections provide easy way to grow and shrink the group of objects. Technically, collection type is a class which internally manages group of objects. We must declare instance of collection class before using it. Some collections allow accessing individual items by using index. On the other hand, there are some collection types which store individual items as a key value pair. So, while reading values from those collections, we need to specify the key of the object rather than specifying the index. So, for accessing individual item for such collections, we need to specify the key. The collections can be found in 4 different namespaces. System.collections is the basic namespace which contains classes like ArrayList and HashTable. Most of the classes in this namespace use object type for every individual item. So, while inserting the data is converted to system.object type. And while retrieving the data, we need to typecast the data back to its original type. We will shortly have a look at what does this mean. The second namespace is system.collections.generic. The classes from these namespace are generic classes. They take data type as a parameter. The uppercase T inside the angle brackets are for type parameters. These type parameters are useful to ensure that only one type of values are being added to the collection. List, stack, queues, dictionaries are some commonly used types from this namespace. There are 2 more namespaces. The namespace system.collections.concurrent contains some classes which provide efficient and thread-safe operations for accessing the collection items from multiple threads. We will try to cover these collections later when we talk about multithreading. The last namespace is system.collections.specialized, which contains some special types of collections like string-only collections, linked list, hybrid dictionaries, etc. We will try to cover the collections from this namespace in some future chapter. Let's discuss a type from system.collections namespace, ArrayList. An ArrayList represents array of objects whose size can be dynamically increased or decreased as required. A sample code is shown here. There are various methods to manage the group of objects represented by an ArrayList instance. Some of the methods which are used in this code snippet are add, which adds a value at the end of ArrayList. Insert, which inserts a value at the specified index. Remove at, which removes an object from the array list from the given index position. And clear, which clears all the values from array list. ArrayList can be accessed using any iteration statement. The code snippet shows usage of for each statement. There is one interesting thing here. We have added few integer items and then we have also added a string item to the same collection. ArrayList allows it. How does it allow this? Basically, it allows any value of system.object type. System.object is the base type for all built-in types and custom types, regardless of whether the type is a value type or a reference type. So, integers are also derived from system.object and string is also derived from system.object. We can add any value of any type to ArrayList because it accepts any value which can be converted to system.object. For a second, we may think how convenient it is. If we want to store values of multiple types in the same collection, then this type ArrayList may appear to be the right solution. But wait, there is a problem with this type. Can you guess what is the issue? The get operation on ArrayList will give you a value which is of type system.object. That means if ArrayList contains values of multiple data types, then every time we need to read the data and we need to typecast it to the appropriate type. This also means that code should always be aware of data types of item at a particular position. If the code makes any mistake by performing typecasting on a wrong value, then an exception is thrown. For example, this line in the code snippet tries to typecast the value at index 2 to the integer type. But at index 2, there is a string. That's why this line would raise an invalid cast exception at runtime. Practically, it may not be valid expectation from the program to know the data type of every individual item in the collection. And that's why we should be very careful while deciding whether we want to use ArrayList as the collection type. Many collection types in system.collections namespace deal with system.object. With all those types, there is one more issue, boxing and unboxing. Now what does this mean? This slide explains the concept of boxing and unboxing. Let's say we declare an int variable x and initialize it with a value 108. As int is a value type, the value 108 will be stored on the stack. Now, in the second step, let's say we assign this value to a variable of system.object type. The type system.object is a reference type. That means its value should be stored on the heap. So when we assign integer value to the object type variable, the integer value 108 will be moved to the heap and the stack would contain a reference to that particular object. This process of implicitly converting a value type to system.object is called as boxing. Boxing may also happen if the value type is getting converted to any interface type. When boxing happens, a new object is created on the heap and then the value from the value type is copied into the new object. Now, let's say in the third step, we typecast the object variable to the integer type as shown here. In this case, the value stored on the heap will be moved to the stack. This process of converting system.object or any reference type value to a value type is called as unboxing. While performing unboxing, the system first checks that the value from the heap can be converted to the target value type. If the conversion is possible, then the value is copied from object on the heap to the instance of value type variable. This boxing and unboxing is related to how value type is represented in the memory. Boxing and unboxing are computationally expensive processes and they may have performance impact on the code. Hence, it is better to avoid them. Now let's come back to ArrayList. There are two basic problems with ArrayList. If we want to use ArrayList to store value type items, then it would cause boxing and unboxing. As we have seen, boxing and unboxing may cause performance impact and hence it may not be a wise idea to store value types in ArrayList collection. Now regardless of value types and reference types, there is another problem with ArrayList. While reading the items, we need to typecast the item to appropriate target type. This means that program should always know the appropriate type of the item that is being read. Even if we figure out some solution to this problem, it may be very error prone. It may not always be possible to know which item is coming next and hence it increases chances of exceptions. As I have mentioned earlier, all the collection types from system.collections namespace deal with system.object. So these two problems exist with all those collection types which are part of system.collections namespace. And because of this, we are not going to have a look at any other collection types from system.collections namespace. Let's now move on to the next namespace. Now let's have a look at collection types from system.collections.generic namespace. This namespace provides various types. All these types are generic. A generic type is a type which takes a data type as a parameter. This parameter is specified between the angle brackets. In these generic collection types, the data type parameter decides which values can be stored in the collection. For example, if we pass int as the data type, the collection can store only integer values. And if we pass string as the data type, the collection can store only strings. Integers will not be allowed in that case. So, generic collection types allow creating strongly typed collections. Adding data to collections or reading data will not require any heavy typecasting. Due to this, the code which uses generic collections is more performant than non-generic collections. Although this namespace contains many types, we are only going to have a look at few of them. The types that we are going to see in this chapter are list, HashSet, key value pair, dictionary, stack, queues, and priority queues. Let's start our discussion with list type. The code snippet here shows how the list of integers can be defined. Some common methods are shown here. We have declared a number list variable. Note that here we have passed int inside the angle brackets, and hence this list allows only integer values. Then we have called add method to insert a few items to the list. We also declared another list variable. This time we have initialized all the values in that list variable inside the curly brackets. After this, we called addRange method. This addRange method takes another list as a parameter. The items from the list which is passed as a parameter are copied to the number list in this case. This would add all the items from another list to number list. Next, there are two important methods, remove_at and remove. The method remove_at needs integer parameter. This integer value should be the index which is present inside the list. It removes the item from that particular index. So if we pass value 2 to this remove_at method, it would remove third item from the list. On the other hand, remove method takes an item as a parameter and that item is removed from the list. So if we pass value 5, the remove method will remove value 5 from the list. We also have used another property, count. This property returns the count of all the items that are present in this list. For iterating over this collection type, we can use any iteration statement. Similar to arrays, we can read data from the list using indexers. We can specify the index inside the square brackets. Lists also have a zero-based index. So if list contains n items, first item will be present at index 0 and the last item will be present at index n-1. However, if we specify the index which does not exist in the list, then it would cause an exception. The last line in this code snippet calls clear method. This method call removes all the items from number list. So this list data structure is very similar to arrays. The only difference is the list can dynamically grow and shrink. As a consumer of that type, our program does not need to write any code for growing or shrinking the list. Everything is managed internally by the list class. We have seen only few methods from this class. I would suggest you to go to documentation and check the remaining methods from the list type. Now let's have a look at another type from system.collections.generic namespace, HashSet. A HashSet is an optimized collection of unordered, unique elements that provide fast lookups and high-performance set operations. This code snippet shows how to use a HashSet. The code snippet first declares set A and initializes it with some value. While initializing, we can see that there is a duplicate value. HashSet ignores the duplicate values, and ultimately set A would contain only 4 unique values. There is another variable, set B, which is declared and initialized with some values. We can see that code snippet has usage of contains method, which returns true if the parameter value is existing in the set. Another method, isProperSubset, can also be used, which takes another set as a parameter and it returns a boolean value. A set is a proper subset of another set only if all of its elements are present in the other subset as well. In this case, set A is not a proper subset of set B and hence this method would return false. HashSet also provide methods to calculate union and intersection of two sets. These methods can be called on an instance of HashSet and they take another HashSet as input parameter. Union with method calculates the union while intersect with method calculates the intersection of two sets. There are some comments in this code snippet. They show how the set A would look after completing union and intersection operations. There is another interesting method, except with. If we call this method on set A, it will return all the elements from set A which are not present in set B. In case of this code snippet, set A and set B contain same values by the time control reaches this except with call, and hence this call makes set A as an empty set. we can also use .count property to find how many values are present in a hash set. And we can also use add method to add the elements to the hash set. And finally, we can use any iteration statement to iterate over hash set. Again, this was a brief overview of this type. I would suggest you to check the documentation for more details. Let's now see what is a dictionary. This type of data structure is a bit different. In dictionary, every item is basically a key value pair, and that's why dictionary takes two type parameters. We need to pass the data type for key, and we also need to pass the data type for value as a parameters inside the angle brackets. Here in this code snippet, we have set the key type to be string and string array as the value type. Then the code snippet shows how to use add method. Add method is used to add a key value pair to the dictionary collection. In our case, key is a string, so we are passing lead1 as a string, and then as a value, we are passing two string values inside the string array. Similarly, on the second line, we are passing lead2 as the key, and then another two values are passed as a value in this particular key value pair. Note that dictionary requires keys to be unique. If we try to add same value again, then add method will throw an exception. Also, because this is a key value pair collection, if we know the key, then we can easily find the corresponding value by using indexer. That's the reason dictionaries are very popular and they are very commonly used for lookups. Here in this code snippet, we wanted to perform lookup using string value, and that's why we have declared the key type to be string. Then, the last lines show how to display all key value pairs present in the dictionary. Here we have used a for each statement. I have intentionally used key value pair type instead of var in the for each statement. We can see that the iteration variable item is of type key value pair, where key is of type string and the value is of type string array. These are the same types that we passed to the dictionary. Okay, this was the brief introduction to the dictionary type. Now let's have a look at another interesting type, stack. A stack is a last in first out data structure. I am not going to explain what stack means here. We will just have a look at this code snippet which demonstrates how to use stack. This class is a generic class and it takes a type as a parameter. Here in this code snippet, we have declared a stack of type string. So we can add string values to the stack. Again, we could have passed any other built-in type or custom type as a type parameter. For example, in order to declare a numeric stack, we could have passed integer. Or else, we can also use any custom type and pass it inside the angle brackets while declaring a stack variable. The stack will only allow values from the type which was used while declaring the stack variable. The stack class provides push method to add the new items to the stack. Pick method returns the value which is present at the top of the stack. It does not remove the value from the stack. Pop method removes the value from the top and returns it. This code snippet also demonstrates how to iterate over items present in the stack. Now let's discuss briefly about the queue type. Queue is a first in first out data structure. C# provides a generic class which takes type as a parameter. We have defined a queue of strings. There are two methods that are used in this code snippet, enqueue and dequeue. Enqueue method is to add a new element to the queue, while dequeue is to remove the element from the queue. There are also other methods to check if the queue is empty or to check the count of items in the queue. Please refer the documentation for knowing other methods and properties. We can also use any iteration statement to iterate over queue as shown here in this code snippet. Priority queue is the new type which was introduced in .NET 6. This is a special type of queue. It is a queue, so it is also a first in and first out type of data structure. Similar to queue type, it also supports enqueue and dequeue methods. There is one important difference. While enqueuing items, we need to specify the items and priority. Then while dequeuing, the highest priority item is returned first. While declaring, we need to pass two types to priority queue. So every item in the priority queue basically has two things, the actual value and the priority. And that's why priority queue takes two types as the parameter. The first type parameter determines the data type of actual value, while the second type parameter determines the data type of priority. Here we have passed two types, string and int. String is the type of value that we want to store in the priority queue, and basically every string value will have some integer priority assigned to it. When priority is a number, by default, the lowest number has the highest priority. So, when we dequeue the elements, item A will have the highest priority and item B will have the lowest priority. In this code snippet, we have not shown dequeue method. Its usage is similar to normal queue type. We don't need to pass priority. The queue will automatically determine the priority and it will return the next value. The last few lines in this code snippet demonstrates the try dequeue method. This method returns a boolean value. It returns true if the item was dequeued successfully. The dequeued item and its priority will be returned as the out parameters. And as shown in this code snippet, for iterating over priority queue, we can use any iteration statement. Okay, this was the brief introduction to the priority queue. We have covered almost all the important types from system.collections.generic namespace. So, to summarize, we have seen what is arrays. We also have discussed about single dimensional arrays and multi-dimensional arrays. We also have seen examples of jagged arrays. After that, we have seen various collection types. Now it is time to open Visual Studio and then use these types in our code.
Let's try to write a program. This program should take 10 numbers as input. There can be duplicate numbers in this input. So our code should filter out the duplicates and should display only the unique numbers from the input. Let's use array for this solution. So first declare array of 10 elements and then we can add a loop which runs 10 times. In every iteration, the loop can ask for input number and then the input number can be converted to integer and this integer value can then be added to the array. Okay, input part is ready. Now the next plan is to read numbers from input array one by one and put it into another array if it is not repeated. So let's declare another array, output array. Its size should also be 10 because that's the maximum number of unique elements user can enter. Let's assume that the first number is a unique number and let's add it to output array. As we know, array length cannot be changed after its declaration. So in order to keep the count of unique numbers, let's declare another variable, unique numbers, and set it to 1. We have added first number in the output array because currently output array is empty. Starting from next number, what the program will do is, it will take a number from input array and then it will check if the number exists in the output array. Then let's write a for loop. Inside this for loop, let's read the number at index I from the input array. Let's call this number as current number. The idea is to check if this number already exists in the output array. If it doesn't exist, that means it is a unique number and hence it should be added to the output array. If the number already exists in the output array, then it should not be added to output again as it is a duplicate occurrence. So for this, let's add inner loop which runs from j equal to 0 until j is less than the value of unique numbers. If the number pointed by index j from the output array is equal to the current value from the input array, then it means that the number is duplicate. So we should break the loop. But while breaking the loop, we also need to convey the outer loop that this number was duplicate. For that, we can declare a boolean variable. Let's add isDuplicate boolean variable, initialize it with false, and when the duplicate element is found in the array, let's set isDuplicate value to true before breaking the loop. In the outer loop now, we can add a condition to check if isDuplicate value is equal to false. If it is equal to false, then we can add the current value to the output array. Okay, our core logic is ready. Now, we just need to write another loop to display the contents of the output array. This loop will now run from index equal to 0 until index is less than the value of unique numbers variable. Our program is ready. Now let's try to run the program. I am providing any random numbers as inputs and we can see that the output correctly displays unique numbers from the input. The program can certainly be optimized further, but the intention here is to make sure that you understand how to use arrays. Now let's remove this code and let's try something interesting. We have declared array of 10 variables and we already know that the last element will be present at index 9. But for now, let's try to use index value 10 for reading a value from input array and let's see what happens. Let's try to run the program and we can see that program is broken. We can see that the program is throwing index out of range exception. It happened because the index that we have specified for reading the value from the array is not between the lower bounds and upper bounds of the array. Okay, let's move on to the next sample. Let's see how the arrays can be resized. An array always has fixed size. So if we want to change the size, we will need to declare another array. So let's declare another array variable. The size of this new array should be 20. After this, we will have to add a loop to copy the values from the older array to the new array. Older array contains only 10 elements and hence we can run the loop from I equal to 0 until I is less than 10. We can make the loop condition dynamic by using length property of the input array as well. The length property returns the size of array. Okay, now inside this loop, assign the value from input array to the new array. After this for statement completes its execution, the new array will have all the values from the older array. But our array variable input ARR is still pointing to the smaller array. So let's assign the new array to the input ARR variable. By doing this, input ARR variable will point to the array which contains 20 elements. And that's how the array can be resized. Now we can print the length of input array at two places. First, we can show what was the length of input array before performing the resize operation, and then we can also add another statement to show the length of input array after resize operation was performed. If we run the program now, the program correctly prints that the size of input array was 10 before performing the resize operation and it was 20 after the resize was done. Okay, C# also has a class with name array. This class provides multiple methods to manipulate arrays. Let's have a look at some of those methods. This array class has a method called resize. This resize method does the same thing that we have done here. That method requires two parameters. The first parameter is the array that needs to be resized, and the second parameter is the new length of the array. The first parameter also has a ref keyword specified. We have not seen what this keyword means. In short, it is to make sure that the new array's value is stored in the input variable which is passed as a parameter. The array class also provides a for each method that can be used to iterate over the array. It takes an array as the first parameter and the second parameter is the action delegate. You can think of action delegate as a reference to a void method. This action delegate receives every individual element from the array as input. So we can just print that input value. If we run the program now, we can see that the for each method is able to display the contents of the input array. The array class also provides two other methods, sort and reverse. As the name suggests, sort method is to sort the input array. If we pass integer array, the numbers will be sorted in ascending order. And then there is this reverse method. This method is to reverse existing order. Note that here we are calling reverse method after the sort, and hence this method call will arrange the elements of array in the descending order. Reverse method does not sort elements in any order. It just reverses the current order of elements. So the last element becomes the first one and the first element becomes the last one. Now, if we run the program, we can see that the program correctly prints the sorted output and the reversed output. Okay, I hope these examples help you to understand how to use arrays. Let's move on. Now again, let's try to write the same program which takes 10 numbers as input and it displays the unique numbers from the input. This time, we are going to use list generic type. So let's declare a list variable and pass integer as the data type. This variable input list should now be populated with 10 numbers. For that, we will run a loop 10 times. In each iteration, it will ask for input. The input will be converted to integer value, and then this integer value can be added to the list by calling add method. While calling add method, the integer value should be passed as a parameter. After completing 10 iterations, this list should be populated with 10 inputs. If you remember, while solving this problem statement using arrays, we took another array variable. This time, we are not going to declare any other list variable. Instead of that, we will run a loop on this particular list and then we will use remove_at method to remove the duplicate occurrences of a number. So let's add a loop which runs from I equal to 0 until I is less than 10 and then read the current value from the list which is pointed by index I. Now the idea is to check all the subsequent numbers from the list to see if there are any duplicate occurrences of the current number. So let's write another for loop which is nested and it starts from j equal to I plus 1 and it runs until j is less than 10. Now inside this inner loop we can add a condition to check if the value pointed by index j is equal to current value. If it is, then remove that item by calling remove_at method and passing j as the parameter. It seems our core logic is ready. Then we can use for each method to display the contents of the list. Do you think there is any problem with this code? Maybe there is no problem. So let's try to run the program. Provide 10 numbers as input, and after 10th input, we can see that the program has thrown the exception. It is saying that the index j is out of range. That means the list contains lesser elements than the current value of index j. Why this exception is thrown? It happened because we are removing the elements. Every time remove at method is called, the count of items in the list is decreased. Let's say after removing first duplicate, the count of list will change from 10 to 9. If there are any further duplicates, then the size of the list will keep on shrinking. But the condition in our inner loop does not consider this fact. It is blindly asking loop to continue 10 times. So what can we do now? We can change the condition. Let's remove this hard-coded value 10 from the condition and then use list.count. So when duplicates are removed, list.count will give the updated value, and thus j will never go out of bounds. Let's also change the condition in the outer loop and let's use list.count there as well. Now let's run the program again. We can provide 10 numbers as input, and this time we can see that the program is working as expected. It is correctly printing the unique numbers from the input. Like array class, list class also provides sort and reverse methods. We can change the program to print the sorted output, which will print the numbers in ascending order, and then we can call the reverse method to reverse the order of elements. We can run the program again, and we can see that the ascending and descending orders are correctly printed by the program. Let's come back to the code and let's try to change this program to implement string sorting. The problem statement is we need to ask multiple words as input. Those words can be provided as a part of same string input, and those words should be separated by comma. So first, let's change our list variable and pass the string as the data type. This time, we want input to contain comma separated list of multiple words. So let's add a console.readline which will return us the input string which contains multiple words. After that, we can call split method and we can pass comma as the parameter. This split operation will return an array. It will contain multiple words that were entered by the user. This returned value, which is an array, can be converted to the list of string by calling toList method. This toList method is an extension method which is part of system.linkUse namespace, and hence a new using statement should be added to import that namespace. This project has implicit usings enabled, which by default imports system.linkUse namespace, and hence I do not need to add the using statement in my code. But if you are using any previous version of .NET which does not support implicit using, or if you are using .NET 6 where implicit usings is disabled, then you might want to add that using statement. Okay, now we have the list of strings. We can add a validation now. This validation should stop the program if the input is invalid. So if the input list is null or if it does not contain any elements, then our program should display the error message, and after displaying the error message, we can add a return statement which stops the execution of the program. Note that return statement just returns the flow of execution from current method to its caller. In our case, we are writing this statement in the main method, and because of that, the program execution will stop. We will discuss about methods and return statements again in some future chapter when we discuss about methods. Okay. Now we can keep rest of the code as it is. The sort method will use the default comparison logic to sort the list of strings, and then the for each method can display the contents of the list. Here, the action variable number can be changed to word, but it is not mandatory. As we are passing list of string as the input parameter to the for each method, the for each method can identify that this variable should be of string type. So even if we do not rename this variable number to word, it would still work. But to have better readability, let's rename it. Now we can run the program and let's enter comma separated list of words. We can see the outcome of the program, and it seems most of the words are sorted correctly except the first one. It is because the space character is being considered while sorting. As all other words contain leading space, they are promoted before the first input kite, which does not have the leading space. So let's come back to the program and let's change the code. We will have to trim the input words. So let's run the loop on list items and then trim the item in each iteration. Let's run the program again, provide some strings as input,
and we can see that the sort order is correct now. Let's now move on to the HashSet. Let's try to write the same program which takes 10 numbers as input and displays the unique numbers from the input. Let's declare a HashSet variable and then pass integer as the type parameter. Now let's run a loop 10 times to ask for inputs. In each iteration, we can ask for input and then the input value can be converted to integer, and then that integer value can be added to the HashSet by using add method. Okay, our HashSet is populated with all the inputs. If you remember correctly, HashSet contains unordered unique elements. Even if we add duplicate elements, HashSet will retain only unique occurrences. So we do not need to apply any additional logic to find the unique elements. We just need to iterate over HashSet and display the items. Let's add a for each loop to iterate over HashSet and display each item by using console.write as shown here. Let's run the program. Let's provide some inputs and we can see that the program is correctly printing the unique values. So we have seen how to use list and HashSets. Let's now write the same program using the dictionary. The idea here is input number will be the key and the value will indicate how many times that input was repeated. So let's declare a dictionary variable like this, where the key type and the value type both are integers. Then write a loop which runs 10 times. Inside this loop, ask for input. Convert that input to the integer. Once we have the input integer, we can check if the dictionary already contains that number. Remember that input is the key in the dictionary. So for that, we will have to check if dictionary contains any key value pair where key is equal to this input. For that, we can use contains key method. This method returns true if the dictionary contains any item whose key matches to past value. So let's give a call to contains key method and pass input number as the parameter. If this key is found in the dictionary, then increase the occurrence count by 1. And if this input number is not found, then add a new key value pair to the dictionary. While adding, we can pass the input number as the first parameter, which becomes the key, and we can pass 1 as the second parameter. Here we are passing 1 to indicate that the input number has occurred exactly once. Okay, so the input part is ready. After this loop completes, we will have our dictionary populated with multiple key value pairs. The keys to all those records will be the input numbers, while the corresponding value will indicate number of occurrences of that input value. So basically, all the keys in our dictionary represent unique numbers from the input. So what we have to do? We just have to print all the keys on the console. Dictionary has a property dictionary.keys. It returns the collection which contains only keys of all the records present in that dictionary. So let's add a for each statement like this to print all the keys from the dictionary. It seems our program is ready. Let's run the program. We can provide some random inputs and then we can see that our program is correctly printing the unique values. Okay, let's move on. Now, let's see how stack can be used. Stack is a last in first out data structure. It basically returns the last element which was pushed to the stack. So this time we are going to use an interesting problem statement. The program is supposed to take a string as input. This input should contain only opening and closing parentheses. Then the program needs to check if the parentheses are balanced. An expression is balanced if both order and count of opening and closing parentheses match. So when a closing bracket is encountered, the previous character should always be an opening bracket. This is very common problem statement and it can be solved by using stack. So let's begin our code and let's take a string as input. Let's trim the input to remove any leading or trailing spaces and let's assume that the input contains only opening and closing brackets. Now let's declare a stack variable. This stack should contain items. Each item should be a character. So let's pass char as the type parameter. Now let's run a for each loop on the input string. In every iteration, check if the loop variable is opening bracket. If it is, then push it to the stack. If it is not the opening bracket and if it is a closing bracket, then call the pop method to get the latest item from the stack. The pop method call removes the item from the stack and it returns it. Let's assign the returned value to a variable. This popped item variable should be equal to opening bracket. If it is not, then we can break the loop and display that expression is not balanced. So outside the for loop, we need to convey somehow that the expression is not balanced. For that, let's declare a boolean variable is balanced, which is by default set to true. Now in this if statement, let's set is balanced is equal to false before breaking the loop. Okay, it seems the core part of our solution is ready. Now after this loop, we need to check if the stack is empty. If the number of opening parentheses and closing parentheses are equal, then the stack will be empty. In addition to that, if isBalanced variable is true, then it means both the order and the count of opening and closing brackets are correct, and hence the program should display the output that the expression is balanced. In the else part, we can add code to display that the expression is not balanced. Let's run the program. Provide a balanced expression this time, and program correctly identifies that the expression is balanced. Now let's run the program again and provide only closing bracket as the input. Surprisingly, our program throws exception. The exception is invalid operation exception. Can you guess why this exception was thrown? This exception occurred because our stack was empty when pop method was trying to remove the element from the stack. So let's come back to the code and let's modify this condition to make sure that stack should not be empty when the closing bracket appears. Let's also add a else block which will execute if both the if conditions specified above evaluate to false. In that case, we can mark isBalanced to false and break the loop. Now let's run the program again. We can see that program correctly works for single closing bracket. It correctly prints that the expression is not balanced. Now let's move on to PriorityQueue. Let's write a simple program to demonstrate how to use PriorityQueue. The program should ask for 10 tasks. For every task, user can input task name and its priority. All those tasks will be added to the priority queue. And then we can iterate over priority queue, and in each iteration, we can call dequeue method. This dequeue method call will remove the highest priority item from the queue, and it will also return it. We can display the returned value on the console. So let's begin the code by declaring a priority queue variable, where the first type parameter should be string and the second type parameter should be integer. Now let's add a loop which runs 10 times. In every iteration, ask for two inputs. The first input is a string and it is the task name, and second input is integer, which is supposed to be priority. After we have these two inputs, let's add a condition to check that the task name is not null or empty string. If it is not, then add it to a priority queue by calling enqueue method. So when this loop is complete, we will have 10 inputs populated in the priority queue. After this, we can add a while statement. This loop will continue until the count of items in the priority queue is greater than 0. In every iteration, let's call dequeue method. This dequeue method removes the element, so it will also change the count of items in the priority queue. The output of dequeue method can be then displayed on the console. Our program is ready now. Let's run the program now. Provide some tasks and their respective priorities as input. After entering 10th task, we can see that the program is correctly printing the tasks based on their priorities. Priority queue itself is a very big topic, and I have used only this simple example to demonstrate how the priority queue should be used in the code. I hope you find all these code examples helpful. This concludes our coding section. Let's move on. Let's now move on to the final section of this chapter. This section shows the exercises that you can try on your own. In the first exercise, read many numbers as input. Then apply some sorting technique to them. You can apply any sorting technique that you know. After that, display the output. Do not use array.sort or list.sort methods. In the second exercise, read a very long string which contains multiple sentences. Then display the count of how many times each word appears in that string. In the third exercise, take a string as input. This string should contain only parentheses, curly brackets, and square brackets. Then the code should check that the pairs and the orders of brackets are correct. In the fourth exercise, input many integers, and then the code should find the third largest integer value. Try not to sort the collection and try to find an alternative solution. Alright guys, that's it from this chapter. Thanks for watching. If you found this content helpful, like this video and subscribe to the channel. If you have any feedback or suggestions, please let me know via comments. Alright, see you in the next chapter. Namaste.